Okay, Xianglin, you can start. For this paper, it seems not on a top tier conference, but we choose this paper because this is a work which taking human efforts or human interaction in the loop. Usually when we are looking to the defects of the deep learning models, I feel that sometimes it is not possible to fully automate the process. Usually the human interactions and human feedbacks may also necessary to correct the model. So here we look into the tolerance of the neural machine translation problems based on the visual interaction. Xianglin will give some more details. Xianglin, please start.
And this paper is published on Graphics Interface 2021. And I believe the authors are from a university in Germany called University of Stuttgart. And the first author is very interested in visualization.
Eye tracking.
Yeah.
Okay.
So remember a little bit recap from recurrent neural network. I believe I have talked about them in my last presentation. And we were talking about a task to predict the sentiments for words in sentences. But here today we can think about another task in NLP, which is called machine translation. You may already know about it, like Google Translate. The difference between this task and the previous task is that the input and output length is different. Here, for example, if you wanted to translate a sentence in Chinese like 早上好 to English, good morning, the input and output lengths do not necessarily to be the same. And so usually neural network for machine translation are based on this encoder-decoder structure. For the encoder part, it would take in all the input and then recursively finally to encode it into a context vector, a fixed size context vector. And then the decoder part would take in this context vector, which contains the information from the input sequence, and then again iteratively output the, like for example, here is the probability for some words until you see a stop sign.
Okay.
Yeah. And the problem with this sequence to sequence structure is that because the context vector is a fixed size vector, and usually we don't know if it can contain the information that needed. So usually now a more popular structure is to combine a mechanism called attention mechanism. So instead of using the context vector to encode all the information from the input sequence, here like in this structure, can I annotate? No.
Okay, okay. Okay, so then.
So here again, we have an encoder part, which represented by the green cell, and the red cell is the input. And after that, this part should be the decoder part. And at each time step for the decoder part, it would how to say it? It would
So basically the attention,
yeah.
each input will connect it. So here, based on your graph, so that means each input, every input will have connections to each output, right?
Yeah.
So by this means, by this weight series, it is allow us to calculate the importance of each input to each output.
Yeah.
Okay, please go on.
Yeah.
But here, so maybe you can explain a little bit about the different. So here, there's a matrix here, right? So the matrix, each column is the 早上好, and each column corresponding to either 早上好, and each row corresponding either to the good morning stop. So maybe you can illustrate a little bit about this matrix.
So what matrix? You mean the
The matrix,
W?
yeah, the matrix W here. So here is this matrix.
So I believe that this matrix should represent. Actually, sorry, I thought I understand, but I'm not sure whether this weight matrix is like a trainable weight or to be calculated by the similarity between like the hidden state in the decoder.
I think it is supposed to be a trainable weight. So basically, the input were actually the 早上好, which is vectorized Chinese characters, and output is supposed to be some English word, but also the vectors translatable to the English word. So here, the weight here is for example here the word good. If we would like to generate good, so basically we would look into all the context, all the context like 早上好, these two tokens. So basically, if it is going to calculate the weights, it will feel that despite this the singular character, so unknown Mandarin here, so usually the word 好 corresponding to good, right? So
Yeah.
but somehow, so here maybe when doing the translation, the weights 1-3, so the weights 1-3 may take a larger value, larger values, and the weights for 早 and 上 will have a smaller values. But somehow 早 and 上 would actually, as a context, will still contribute a little for such a translation. So basically, they were trying to include more weights here to learn the context of the sentence.
Yeah,
I think that is the
that is-
basics. I suggest telling you better to recap it. This is a mechanism. If you do not explain it well or in a very articulate way, maybe means that somehow either you cannot organize it in a logical way, or you may have there's some culture, there's some concepts. You still may feel very ambiguous or fuzzy about some concepts for the attention mechanism.
Sorry, I didn't do my research before this presentation.
Let's keep going on. So attention basically is the mechanism to consider the context of the input or different layers and build the importance of contributions from each input to each output. So maybe this definition is not 100% accurate, but it conveys such semantics. And also, there's a very famous paper called Attention is All You Need, which was published in 5 or 6 years ago. So that paper, the proposal of the publication of the paper is almost like a renovation. And after that, the LSTM will be used that becomes less and less popular, and people began to use attention mechanism and integrate into a one architecture called a transformer, and using it for using a lot of the natural language processing techniques.
Yeah. And basically, all you need to know about attention in this paper is those words contains information on like how much the input contribute to some outputs. So here, for example, for the good, by the weight, you can see that maybe how should contribute it more for why this model predicts C1 as good. Yeah, and let me clear the annotation. Yeah, and often some problems happen in machine translation is first is called over translation. That means one words might be translated over and over again. So here, for example, in this case, I believe this word in German should have the meaning of examples. However, in the translation part, the model gives out examples of examples. So this is called over translation. And also it has problem of under translation. So like in the second example, here, like this part are not translated at all. And the second problem is called rare words. It means if you train your recurrent neural network on some general text, and then somehow when you input some new documents and it contains words that not in your general text, then the model might gives the wrong translation.
Oh, by the way, Xianglin, so sorry for interrupting. The tool, this visualization tool provided by the authors is available publicly available.
You mean their code is?
Yeah, they are called a tool. Yeah.
Oh yeah.
Yeah.
Their code.
Hey, Yufan, is Yufan there? Oh, Yufan.
Yeah.
Yeah, so maybe you can later consider using their tools, because you can see such a translation problems may also happens on the code translation. So if it is possible, we can using some visualizing tool to debugging or understanding why some query fails. It might also be useful. Of course, maybe let's look at what details given by Xianglin to make such decisions. But anyway, so we do feel a little bit fuzzy and confusions about some model decisions. It's better for us to build such facilities to fully understand the reason.
Yeah, I mentioned this paper last meeting, last Saturday. I also read this paper and
okay. So you're also the reader of this paper. Okay, so maybe if you are already read the papers, you can make comments or during Xianglin's presentation.
And the third problem is long sentences and short sentences. Oh yeah, and it has the same problem with the over translation and under translation. In practice, we believe that short sentences are easily to be over translated, and long sentences are easily to be under translated. And the fourth problem is related to some domain-specific words and sentences that requires high-quality translation. So again, this is about a problem to domain adaptation. If you train your neural network on some general text, and then you wanted to translate some domain-specific documents, for example, in medicine or law, then those domain-specific words are easily to be translated wrong. So in order to fix those problems, they propose this visual system for neural machine translated, or for neural machine translation. And first, they propose 7 requirements that this visual system should meet. I will briefly to introduce those requirements, and later in the detailed explanation for their paper, we would again to see how they fulfill those requirements. So the first is called automatic translation. That means they think the visual system should clearly show the text that you wanted to translate, and also the translation given by your neural machine translation model. And the second requirement, overview. This is quite. That means your main theme should requires the automatic translation and some filter function. So later we will talk about the overview of their
So I still have a little bit
Mm.
confused about automatic translation.
uh,
So this translation is supposed to have a source and target, and this is a visual system for
yeah.
an MT. So what is here? So the translation functions for the visual system, right? And what is the source and what is targeted for such translation?
The source is the sentences that you want to translate.
The input of the model.
Yeah, and then the output text given by the model.
So that is just the input output of the subject model. And so this R1 is a requirement, right?
Yeah.
And why is this supposed to be the requirement of the visual system? Because
It's
such
yeah.
function of automatic translation is inherent from an MT, right? Why is there such a requirement?
Because they think because the visual system provides an opportunity for the expert to correct those sentences, right? So of course they should first that the expert to see the translation given by the model, then the expert can correct the translation. I think it's a very basic requirement.
Okay, let's keep going on.
And the third requirement should be it should support function like find, filter, and select relevant sentences based on some metric for the machine translation problem. For example, like confidence or other metrics we will talk about. They should support this filter function. And the fourth requirement is called visualize and modify sentences. And again, it's very obvious. It should provide an view for the expert to see the translation given by the model and then to modify the sentences, modify some translation words easily. And the fifth requirement is to update the model and translation based on the correction given by human and then retrain the model. And the R6 requirement is called generalizability and extendability. That means it should not only, this visual system should not only apply to one architecture, but they think it should be easily to adapt to a quite wide range of architecture. As long as they have this encoder-decoder structure, then it should be easily adapted to any architecture. And the seventh requirement is the target group. They believe this visual system should not only be used by experts in neural machine translation, but also included a wide variety groups of people, like even some people who only knows nothing about neural machine translation can easily modify the sentences.
So
yeah,
basically, I think the key point is that the data model and the translation. So consider, suppose we have already trained a model which can translate from the German to English. So I think it's kind of tricky for how to, it's more like it still come back to the problem of active learning, right? So we have so many sentences, and which kind of sentence should send it to the expert or the human to evaluate them? And when the human thinks some translation is not that appropriate, and how to allow the users to mark or provide a feedback on part of the predictions. And when they provide this kind of feedback, and how the machine can take those feedback to further learn it. For example, when the authors or when the people are marking things that the German word would translate to the English words, and maybe the mistake is just in a partial sentence, right? And how to leverage that feedback on a portion of the sentence so that the machine can learn better. So that is a very tricky part. And
I would.
yeah, I think this work is very, it's kind of relevant to many aspects of research. And for Yufan, maybe you can look into whether this tool is usable for us to apply on the code translation project, right? Or the code search project. So basically, so that is because the state of the work are all based on your method. So for Xianglin, maybe you can think about how to leverage this framework into the DBI to see whether we can provide more intuitive feedback from this paper. Okay.
And I believe that the third requirement is very similar to how we should find some informative point from the unlabeled data, like unlabeled data pool.
Okay.
Yeah, but anyway, and here for the sixth requirement, because they talk about the extensibility to other architecture, they talk about the transformer architecture. I believe that should be the state-of-the-art architecture for neural machine translation, and they talk about how to adapt to this transformer architecture, but I don't that constitute a section, but I don't think that should be quite. We don't need to know the details about this part.
And also, by the way, so for now, DBI is just designed for computer vision techniques. But you can put some thought whether DBI is extensible for the neural net processing. Okay.
Yeah. And then first, this is the main view of their visual system, and which can start from the matrix view, and is this part. This part is the matrix view, and the first matrix called document order, which just represent the index of each sentences. And then the second metric is confidence. So it's the probability that, or how much confident this model with its prediction. And the third, where is please.
No. So I'm not saying anything, but I encourage the other students or other audience to ask questions here.
Oh, and the third metric is called coverage penalty. That means if you, for example, we talked about the attention mechanism before, and we know that how much the input contributes to the output, and if some words are not be covered, then they would have a high coverage penalty. And the fourth is the sentence length. It aims to fix the problem of long sentences, because we already know that long sentences are easily to be under-translated. So they included this metric. And the last one is called key phrases. That means the phrase in your uploaded documents are not seen in a trained text. Then they would list those key phrases, and that.
Sorry. So will you please repeat what is key phrases?
That means in the setting of their visual system, it's first you would have a model trained using some general text, right? And then you can upload a new document by yourself and see the translation given by their model. So the key phrase means those words are not seen in the training data set. So I believe that those words are more easy or are easier to be mistranslated.
So the key phrases is about the number of the phrases or the number of phrases which has not appeared in the training corpus. So here each, so for example, giving such a line here. So suppose I draw a line here. Suppose this line is supposed to be here. It means that so each consecutive line is supposed to be a sentence. I'm right.
Yes.
So for example, giving my red line here, it means that giving sentence, its order is on this level, its confidence is on this level. And here, may I be more specific? Would it please be more specific on the document order? So,
what?
Yes, for machine translation, I assume that each sample is just a sentence, or each sample is a document.
Yeah. Oh, it's a sentence. Here, each line represents a sentence.
Okay, so the document is that when you take document and translate each sentence in the document, it just mentions the orders of each sentence in that document. Am I right?
Yes.
Okay. So basically, it is but for machine translation, the order does not matter that much, right? So the document order will not be the input of the model.
No, it's not so important, but anyways, you can.
But anyway, so somehow it's a way to locate a sentence in a document.
Yeah, and by using those metrics, you can here you can see a sign. So here, I believe because the document order is highlighted, so now the sentence are listed by the order of document index. But user can also specify which metrics they wanted to use to filter the sentences. And also they point out that the line plot, instead of the bar chart, should be easier to detect some outliners. Yeah.
So for example, for this line, it means that this is a super long sentence, and it is under translated, and am I right? It's a very long. So it's a larger. So this means a large sentence, long sentence. So it have low confidence.
Maybe it means the sentence length is short.
Okay, so the higher the position, the shorter.
Oh.
But here you can see the coverage penalty is high, is low.
It should be low, right?
It is a little bit concentration.
I don't know how they.
So I just speak out my interpretation. Just please correct me if I'm wrong. So if it is my interpretation, that means this sentence appear in the maybe one set of location. There appears to be a very long sentence. Given this long sentence, the machine have a low confidence, and the reason for it have low confidence because a larger portion of these tokens or words is not translated or under translated, because the under translated sentence usually have a large coverage penalty. That is my intuition and penalties. And also when we're looking to here, it means that a lot of tokens in the sentence does not appear in the focus. And it is supposed to be an offline. So this is my interpretation. May or may not be 100% accurate. But usually the visualization may allow us to interpret the sentence in such a way.
Yeah, I believe that's the correct interpretation of this matrix view. Yeah.
Sorry, may I ask, is top is less or bottom is less? I mean, from top to bottom.
Yeah. The thing is, I'm not so sure, but if I don't think that should be a problem because
I think I present a logically complete interpretation, but not be factual. May not be factual, but I think that's supposed to be a way be
because,
interpreted based on such a visualization.
Yeah, because based on your, interpretation, for example, here is less, but here is high. Here is also.
Can you mark? I cannot see
sorry.
what is here.
Sorry. So, change another one. This part, it means the confidence is low. This is 10K is high. This is sentence length is high. This is
the key phrase is low. Key phrase is low means many of these words does not appear in the training corpus.
Okay. Oh, yeah. I just confused why this part has so many. Yeah.
Okay.
So,
but I think this is specifically related to how they design their view. But as long as you know how to which part which side is larger, which side is
yeah, I got it. Yeah, maybe this means keyword. Maybe the lower means the more likely to appear. I also don't know the precision, the precise measurement, but I think the advantage of such a visualization allows us to see the distribution. So there it also possible for us to organize it. I mean a table, right, based on the document order, confidence, public penalty, etc. But we cannot see how these samples are distributed over such a measurement. And based on such a visualization, it allows to look into the sample distribution based on it. Yeah.
So yeah, this is the matrix view. And then we also have the key phrase, another key phrase view. I circled it with the red box. Yeah, this part. And it has some checkbox. In the first key phrase is MU. So in Germany, it means machine translation. But it appears 29 times in this new document, but it's not in a training data set. So this function is if you check the MU, and then it can filter out the sentences that contains this word MU in the document, and the expert can further to modify the translation. Yeah, you can see the 29 appears here, and it means how many times it appears in your new documents. And the last part of the menu is called, document view. The document view is this part. So it contains all the sentences in your new document. And first, it appears in source language and then in translation. And later, the check means whether you accept the translation of this sentence or not. If not, you can set the flag to be red, and then further you can go into a detailed view. Later we would talk about this detailed view, but if you are not happy with the translation, you can set the flag to be red, and then click the modified this part to further modify it. And this part I didn't see the explanation of this, so I'm not sure what it means. And the last part is again the metrics of these sentences show in the bar chart. So each one represents the metrics shown in the previous view.
Okay.
And then it's the sentence view. If you are not happy with the translation given by the model, you can further enter this view. And first, the first one is called detail view, and it shows the source sentence and translation. And here you can see there are 5 buttons. You can use the 5 buttons to do some post editing. First, you can modify the translation here in the detail view, and yeah, you can, after you are happy with the translation, you can accept this. And further, you can make some changes like mark sentences, reset, retranslate, and return, and whatever. And then it's the attention view. Remember we talked about the attention weights in the background, and here.
Can you repeat, please go back to the previous slide. So here the buttons means accept retranslation. So what if I click the retranslate, the button to retranslate, or here does it allow user to correct honestly or correct the several words during the translation?
I'm sorry, can you?
I'm saying that I think assume that this is a way for the authors designed to provide feedback, right? Or it's not a place.
It's the place to.
So for example, if I'm not satisfied with certain translation, for example, the word increasing, I want to change it into a word increasing, or the article, or the article R, I want to change it into is, a word is. So is that possible? Is it allow us to provide such a correction on the translation?
So, sorry, your voice is not so clear. So
okay.
Can you?
Okay, is that better? Hello?
Oh yeah, now it's better.
So I'm asking that given a sentence, maybe during the translation, only a portion of sentence or several words in the sentence are not satisfying, but the overall framework is justified, right? It's quite possible.
Yeah.
Right? So here it seems to be a feedback mechanism. So does it allow the user to correct several words on the translated sentence?
Yes.
Okay, so it allows you to make the to correct the words, right?
Yes.
Okay, so maybe I missed it. So there's a branch. So for example, there's 4 branches there. So that means that it actually means the different candidates for such a translation.
Yeah. So we will talk about this in detail in later slides. Yeah, I'm only talking about the first detail view. They are saying they can let the user to freely modify the translation, but yeah, you can see it later, and then we can first and then I
understand it. So also when they make modifications, they're supposed to be some mechanism to do the back propagations or other ways to update the model, right?
They just say that they can use the correction to retrain their model, but they didn't talk about the detail on how they retrain the model.
Yeah, so here it's more like given the patch of the programs, but for different, if we just make a patch for the weights, and the weights will influence the influence is global. That means maybe we can fix the sentence for these samples, but it may bring the negative impact on the other translation of the other samples. So kind of interesting. So not like the humans. So if it's human beings, we can just add rules there. And but if for the neural network model, we would like to make one sample to have a correct prediction while preserving the accuracy on the other samples. I feel it is a bit tricky there.
I don't think they talk about that.
Yeah, I understand. If they talk about it, they're supposed to be tying for a better value instead of the graphical interface. But I think it would be worthwhile to think about it at this point.
Okay, and then it's the attention view. We talk about the weight of the attention can represent how much the source words contributed to the prediction of output words. And if you zoom in this attention section, yeah, this part, and you brush over some words, and you can see the link between the input and output. And if the thicker the line is, then the larger the weight is. And by doing this, they think it can be a solution to the over translation and under translation problem, because if there happens to be over translation problem, then and then it should look like this. The input contributes to, like here, it contributes to both the examples, and for human, they can know that there's a over translation problem. And again, if there's an under translation problem, they should see that some words might have no links to other words. And so human can modify this part.
It is just a gut feeling, right? So, so sometimes one word in one languages may need to use multiple words to interpret or translate it. And for in other case, maybe because when the language translations, usually, sometimes even for Chinese, the word is more concise. For English, the word the length of sentence may be larger. So when doing such a translation from English to Chinese, we definitely need to ignore some words in English. And when we translate Chinese to English, probably for some of the point, because the Chinese have the proverb, and they're in very short word and taken from some Asian histories. If we want to translate the ideas, we some so very short phrase, we're definitely responding to a larger number of the English words. That is all possible, right? So it's hard to make such a heuristic to saying that if a word corresponding to multiple sentences, it is kind of the over translation, and vice versa is under translation. So we need manual investigation to see whether there's over translation and under translation.
Yeah, but anyway, it's a help to detect such a problem.
Okay.
And then the last part, the tree structure of the sentence, is called beam search view. But here we should first introduce what is beam search. So in practice, if you use the model to predict the translation output, usually we would only find one best solution. But here, we wanted to see whether there are some other alternatives. So for the beam search solution is first, suppose we would wanted to find 3 solutions. And then in the first step, it would find the top 3 words with the highest probability given the input sentence, and then record those 3 words. And then in the step 2, for each of those 3 words, that would find 3 best pairs. For the first and second words based on the conditional probability. That means, let's say you have 1,000 words in your vocabulary, and then you have top 3 words. So in this case, you would find
This case, the number of candidates was supposed to be exponential or exponentially increased, right?
Not exponentially.
So the first we choose the first top 3. And
Yeah, first you choose the top 3, and then in the second step you find the best 3 pairs. So if you have 1,000 words in your vocabulary, then in this case you would find 3 best pairs from the 3,000 pairs, right?
Okay, so that point is that, for example, given the sentence, or this sentence is whatever language it is, and we want to translate it in English. The first word we were looking to pick the top 3 tokens, right? Let's say token 1, token 2.
Yeah.
3, right? And so maybe these 3 tokens may be different or maybe the same. They have to be different, right? So given the token 1, it means the top ones it is, and we need to check the next token or next word after the T1, right? And then we will have another.
Yeah. And then you would have 1,000 pairs, and then for the second word you would again find 1,000 pairs, and then you would
1,000 pairs or 1,000
pairs.
Why it will become a pair? Pair means the T1, 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 or T1, T1.
Yeah.
T21, right? T21, T23, T23. So they will construct a pair like this, right?
Yes.
Okay, so but here, so suppose we take 2 steps, there's supposed to be 9 pairs here. If we choosing if we take the top 3 for each step, we will have 9 pairs. So my question is that what will that be?
From those, then they would save again the 3 best pairs.
Oh, I got it. So on the second steps, despite we're generating 9 alternatives, but we just compare about 3 best pairs for that.
Yeah, and then again for the third step, you would again save the 3 best, then it's triplets. Okay. And finally, you would have 3 best.
Yeah, so that is a very interesting algorithm. So there's supposed to be an interesting algorithms. So have you prepared a question for the audience to answer?
Here.
Right.
No.
So maybe I ask
okay.
here. So once we generate a pair, so at the first steps it is an individual word. On the second steps it will be created top 3 pairs. On the third step there will be top 3 tuples, right? And then for the fourth it will be 3 quadruples. And for giving each partial sentence, and how do we evaluate the score? When we chose the top 10, right? The top 3, and how do we evaluate the score?
It's the
maybe we can ask an audience here.
Oh,
okay. Maybe we ask Yufan to have a try. Hello, Yufan.
What is evaluate? What is evaluate the score? What is the meaning of the evaluate this word?
Evaluate means that Xianglin mentioned that suppose we on the first steps we should choose the top 3 tuples, and there must be a way to evaluate which is the number 1 tuple, which is the number 2 tuple, right? So and how to calculate the score there.
Oh, how to calculate the score?
Yeah.
I think it's math likelihood.
Okay. Yeah, I think that's basically we just need to multiply a consecutive multiplications of all the tokens in the sentence, right?
Yeah, I just guess.
Okay, I suggest that we make this very clear because Bing search is a very primitive and a fundamental algorithms for evaluating the model translation, I think. So usually the Bing search will be used a lot in machine learning translation tasks. I encourage you understand the details, and that's basically just an algorithm. Just understand it is not a difficult task. Okay, keep going on.
Yeah, and then this bin search algorithm is quite useful to offer some alternative translations so that the expert don't need to they can just maybe select one and accept not the best one but second best one. So here, for example, they offer 3 alternative translation and represented in a tree-based structure. And if you zoom in like this part, you will see here, for example, the original translation is the MWC. I'm not sure what that means, but it can suggest some alternatives like M and F, and user can also do some post editing and add in the correct translation and click on the accept button, and that's the whole process of correct.
But the user is only allowed to edit on the tree instead of the file output.
No, the tree is for, like, for example, you may only modify some words, but in the detail view we talked about before, they can also modify the sentence there.
Okay, so the tree is just for user to select.
Yeah, because I believe if
But there are sentences some showing that the user correction, right? Oh, okay. So that means that when user corrects the original sentence or the output sentence, it will add such a correction. It will merge such correction into the tree.
oh
That's just my hypothesis.
you mean if they correct the
So here,
sentence?
so you can see there's 2 parts. This part is the final output. This part is output. And this is actually the output alternative. That's called an OA, is output alternative. Right?
Oh yeah.
So the user actually, if I'm the one who designed the tool, I will only allow the user to modify its output. But it is possible that when, for example, I'm going to change this word into another 3 word, right? So that maybe that is the way I think is a better or a more appropriate translation. And after I make such an addition, I will try to merge my modification, because if I change the sentence, basically I will create another branch. The original branches have a sentence focus, but actually I create another branch here. So basically I will just merge my branch into this another output alternative to show the difference. So this is my hypothesis. If I'm the one who on the tool, I may do something this. May do something like this.
I didn't get it.
I didn't get my point.
I didn't get it.
The point is that, okay, so the point is that this is output, right? Because this is output the user can see. So
Yeah.
this is the recommended output, right? And this is alternative, right? So the red box is alternative. So here for this sentence, there are supposed to be 4 alternative sentences.
The top branch of the tree structure is the output.
Okay, I understand. So okay, so there's three alternatives, right?
Yeah.
There are 3 alternatives here. So here maybe I'm still not satisfied with the output, right? So for example, I would like to change this sentence into some word like hello.
Oh, I see.
In this case, I will create another branch here.
Yeah.
I will highlight this branch saying that despite I using Bing search algorithms to generate those candidates, nevertheless, I will try to create another branch that is my version. And when we're going to retrain the model, I will actually taking or put more weights into my versions. So in this case, I raise this point because I see in your right part, there's the user corrections and update sentences afterwards. So I have a hypothesis that the user modifications will be merged into the tree as part of visualization.
And
This is my hypothesis. So I ask you.
I'm not sure. I'm not sure.
Yeah. So my point is that I think it's may not be appropriate for a user to make the corrections based on tree, because tree is just a recommended candidates. If we want to make the feedback, we have to make the feedback on the final output instead of the candidates. Hello?
Yeah.
Okay. So maybe let's keep this one. Let's keep going on.
And again, one last point to it slice is each word is represented by a circle, and the circle has different colors. And if the colors are darker, then that means the word probability is higher. So you may find those circle that has lighter color and see whether there's some problem.
Okay, let's continue.
Yeah, and then in the fifth part, which is the model fine-tuning and retranslation, they really didn't say much about this part. They just said after you modify the sentence, they would put them back to retrain the model. And that's all.
Just for to retrain a model, but usually the user feedback should take into more consideration. Might be, but this is more like
they only train the model using those like marked sentences.
then there will be overfitting, right? Then we will introduce the risk of overfitting. Just like it's more like an active learning, right? So we sample a few sentences, and when the user provide feedback, actually it means that user remark the sentence or remark a few samples and feed into the original data to retrain them. Just like we will apply active learning, it's just on the feedback to the samples, then the classification boundaries will be reshaped in a cartonic or a dramatic way. That is also what we want.
Yeah, I think this would be a problem actually, because in their user case study, they claim that after they retrain the model using those correct sentences, and later to retranslate all the sentences, and the quality of translation improve. But I think they should use, for example, a test document to see whether the translation really improved or not.
Yeah,
anyway.
so basically, so I just raised the questions, and not now, maybe Yufan or Ruofan, you know that. So, or maybe Dr. Xiao, you feel it. So is there any active learning research applied on NLP? Right, so there's another, I suppose there's another direction for to go with. Okay, let's keep going on.
Oh, and yeah, so how they conduct the case study is first, they use a general text data set, which I assume is quite famous, and then trained the LSTM-based RNN with attention mechanism on the data set. And later they uploaded a document from the Wikipedia about machine translation to the system and see the result. And first is the problem of rare words. Here the example is the MU in Germany should translate to MT, the machine translation in English, but the training data set do not contain the MU words. So here they use the Keyphrase View to filter all the sentences contain these words, and the MU appears 29 times, but I believe they correct 5 out of 29, and later in their retranslation, all of them are correctly translated. And then the over-translation problem and under-translation problem, those two sentences are, we talked about those two sentences before. but they are just examples. They claim that they fix some over translation problem and under translation problem.
How do they fix them? So they mark it, so they provide a feedback and not more to retrain it.
Yeah, so here, for example, the examples appears twice in the sentence. So maybe they
I think that is a very interesting stuff, but they think they, so you can see. So maybe I just make comments on the conference ranking. I think conference ranking can be too objective and introduce bias. But if we would like to publish paper in top tier conferences, it will have to go through more rigorous review process. Just like originally we find that the ICSE comments is not that good. Anyway, giving such a high ranking, the reviewer are definitely very picky. So we can see this study is very, very preliminary. And if I'm the one who review the paper, so definitely will receive a lot of criticisms. Anyway, this idea is very interesting. And how to adapt those natural language sentence and retrain the models, that was really an interesting topics. So I think that's a major difference between the paper published in the high-ranking conference and low-ranking. So for low-ranking conferences, maybe they just propose interesting ideas, and maybe the interesting idea is always merits. Right? Of course, it would be good that it provides some tools, but for some high-ranking conferences, the idea must be novel, and the approach must be systematic, and the variations must be strong. So all these approach and this doing that kind of work is often maybe it's just propose or publish some preliminary or some prototype, research prototype, but that prototype must be runnable and maybe have this high potential to be incorporated into industry application. Okay. Let's keep going on.
And yeah, they do have a detailed explanation maybe on those two sentences, but given that I don't know Germany, so I don't know.
Yes. So if we consider it as a systematic approach, they have a lot of points. They have a lot of points of vulnerabilities to attack. But anyway, it is good for us to inspire us to look for some new works. But let's keep going on.
Yeah, and the correction should look like this in the document view. And yes, in the case study result, they show that the MUR all correctly translated and the translation quality improved. But personally, I think maybe they should use the test document, which also related to the machine translation problem, and to compare
the ranking of this paper, the conference. I'm not sure the ranking of the conference where this paper is published. But if it's rank 2 or rank 3, you can see. Sometimes I also find that in rank 2 papers, the evaluation is just here. Okay, so have you prepared any questions to ask the audience?
No, because I think this is more like an introduction paper rather than some research-based paper.
Okay, so Xianglin, would you please find the tools and publish in our group?
Oh, you mean the code?
Yeah, I would like to. I'm very interested. I'm very curious, especially that if or maybe Yihao is not here, to try the tools, and it'll be very useful for us to see the correction.
Yeah, although I didn't run their code, but I checked their document. It is well written, so I believe it should be quite easy to.
Yeah. And also in the future, I'm thinking about the future work of DBI. I think the DBI will publish anyway in a Tokyo conference, but you can put more thought into what next. What is next? Active learning or extension the framework into the neural network, into the natural language processing. So that is very interesting. So here, maybe based on this idea, you can think about word embeddings. So for now, we are just to visualize the images, samples on updated word base. But later, maybe we can consider the word embedding stuff but that's just a problem. That is just my gut feelings. We can talk more details later.
Yeah. And later in the last section, it contains a user study to verify how other people think of their tool.
That is very subjective. Let's forget this.
Oh, okay. And yeah,
So
because I believe this user study.
I've done a lot of user studies before. So usually, if you want to get a very good result, you find a good friend for that.
And this should be used for the seventh requirement, because they wanted to targeted group, not only the developer of NMT, but also other group of people. So
You're very subjective. That is problems of some psychological research.
Yeah.
So a lot of psychology approach to conduct your studies, and it takes the replacement, or usually in medical research, someone taking the medicine and someone take a replacement, and they conduct user study for that. But for psychology research, they will do something like this, and for software engineering, and maybe for this kind of the HCI research. So those, anyway, if it is research, it have to be quantitative analysis. So but anyway, the tool itself involves human. So the researchers have no choice but to conduct user study. And when conduct user studies, it will be a lot of flaws. For example, the experiment can hardly be replicated. And also, the subject we choose supposed to be very vulnerable to bias. But anyway, so from my point of view, the user studies is supposed to be plus for evaluating your approach, but some simulated experiment or some fully automated experiment is very necessary. So that is also the way that we want to avoid user studies, because the user studies per se, it takes a lot of effort, and the results will usually invite questions.
Yeah, basically that's all. And I checked the open review, and they think the user study is not strong enough. That's the only weakness in their paper. Yeah.
Okay, so that is the very since Xianglin, the preparation that we grew, and maybe just you can send out the links to the and especially for Yufan, and you can help me at Yufan and Yihao to let them to have a look at the tool. Okay, next one, how about Darien? So this is Darien's first presentations for software testing. Darien, are you there?
Yeah, can you see the slide?
Yes, we can.
Okay, great. Hi everyone. So we are presenting this paper on unit test generation for machine learning libraries.
Okay. So maybe I can recap a little bit. So usually software testing, it is supposed to be a very practical and long-standing topics in the field of software engineering. So I think all of you understand that software engineering research is kind of research to automate the programming. So during the programming, we need to debugging, testing, design, documenting the code. So the people were actually thinking whether all these tasks can be fully automated. And just for Yufan's work is trying to translate the languages into the code per se. And for Darien's work is trying to automatically testing the code or generating the test code for the code. So here it is very interesting topics is that the code per se will be used for many different domains. For example, for websites, there's a code. And for the normal Java program, there's code. For machine learning code, there's code. And the test case for testing different programs supposed to have different features. And Darien today will just present how the test case generations for machine learning libraries, for example, WeClass, or maybe in the future, if we want to generate test cases for TensorFlow or PyTorch programs, and what's supposed to be, and what is the best test case for it. Okay, Darren, please go up. So maybe you can introduce the author first.
Yeah, thanks, Linear. So these are the authors. There are 6 authors. You can see most of them are PhD candidates, and they largely have a similar interests in regarding either machine learning or software engineering and testing. Yeah, I'm not quite sure what else to mention about them here. Yeah, so the background is that nowadays we have automated test generation tools such as Rendup or EvoSuite, which are highly effective on general software projects. So these are the general software projects, like stuff that we use, those kind of tools and stuff. And we haven't really seen much use of them on machine learning libraries yet. And this coupled with a wide adoption of machine learning models and software systems. So nowadays we are seeing more and more uses of machine learning to do many different things in software systems. And so this brings about the question of what is the effectiveness of our software test generation tools on these machine learning models, and how effective are they, and what improvements can we expect to see, and so on. So regarding automated unit test generation, there are 2 approaches that the paper considers: the feedback-directed approach and the search-based approach. And so there's one canonical tool that the paper uses for each one. Rendup uses the feedback-directed approach, where they generate test inputs. They have an initial test input, use it to generate another test, so and so on, and to keep generating new generation of tests until they increase the coverage. Whereas EvoSuite goes for a search-based approach, where they transform the test generation into optimization problem and use different algorithms to mutate the tests and to optimize the tests, and so on. So we talk more about the search-based software testing optimization problem.
The comment is here. So basically the feedback-based approach are almost equivalent to the search-based tools, because the feedback in the feedback-based approach is just the finite form in search-based testing. So once we generate test cases, there is supposed to be a score there. The score per se can be considered kind of feedback.
Okay. Oh, okay. I actually didn't know that. I thought there was separate. Yeah.
So basically, they are fundamentally speaking, they are actually equivalent.
Okay. Okay. Yeah. We'll talk a bit more about search-based, because that's what I'm going to be doing for FYP, and some background will be useful as well, I guess. So search-based software testing focuses on turning the test generation problem into optimization problem. So the idea of this is that you have a fitness function that grades the tests, how well the tests do in terms of how well they improve coverage, and then you evolve the tests iteratively until you get the desired coverage, or you meet the desired time budget. So the optimization problem has 3 aspects: the encoding of solutions, being that we have, in this case, tests, and we're going to encode such that a similar test, for example, are also neighbors in the representational space. Which means, for example, if you change like a small thing in one test, it shouldn't be, in terms of distance, it shouldn't be too far away from the other tests. You have this objective function, which is used essentially the distance function. It's used to test the distance from the optimal solution. And better solutions get the better objective values. And the reason why we use better here as opposed to like a higher or lower value is because in some cases it might be a cost function. For example, you want to reduce the cost of something. Might also be a score in other cases, but you want to increase the score instead. So it really differs depending on the situation at hand. And lastly, we talk about the evolution strategy. So once we have tests, and once we have a fitness function for the tests, how we evolve the test from iteration to iteration. There are different algorithms here. Hill climbing is a standard. You look for a local optimum. You just make small iterative changes and so on. And also other ones such as simulated annealing or genetic algorithms, which is the one that I'm sure the audience is more familiar with of the 3. So this example of optimization problem. So we just have a color of a set of objects. We encode it as a 3-vector of RGB space, and our distance function or optimization function is just the distance between the point and the absolute rate. Want to optimize it to becoming rate, for example. So on the right, we just see a diagram visualizing this. Next, we talk about machine learning, the other point of this whole thing. And the aim of machine learning is to make meaningful inferences given some pre-existing data. And there are 3 steps to constructing the machine learning model. You collect the data first, but the data itself cannot be applied directly. Instead, you have to pre-process the data. For example, you might have to remove noise, you might have to change the format to make it suitable for the model, and so on. And finally, once you have this clean process data, you apply the learning algorithm and you get your model. So the authors of this paper decided to break down the code in the machine learning libraries into 3 different categories, broadly speaking. Data processing, so it's just what we mentioned earlier, pre-processing the data, cleaning the data, so and so on, format conversion. And then we have the core model, which is implementing the learning algorithms and so on. And finally, the util, which is just miscellaneous things like model evaluation. I think they mentioned like something like a confusion matrix, I'm not sure. But basically, it's just auxiliary functions that don't tie into either the data processing or the core model. And so here we see a visual representation, and the ratios are actually not random. So the authors actually found later on that the ratios of the code is something like, I think 54% util on average, and the core model takes up the other something like 30%, and the data processing a very small amount of it. Just some background. Yeah. Now we'll talk about unit testing. So the authors use 2 metrics to evaluate unit test quality: code coverage and mutation score. So code coverage, I'm sure most people are familiar with. It's in this case, they use instruction coverage, which is just the amount of code executed amidst by the test suite. And now we talk about mutation score, which is the more foreign one, probably. So the idea is that we have this thing called a mutant, which is just the original program, test program. Sorry, no, the original program that's under test, the software under test, with an additional mutator statement inside. So we change the statement using a mutation operator. So maybe we convert one plus sign to a minus sign.
We interrupted it. So I find it that your speed is very fast. I hope that the audience may get a bit confused about here. So I suggest that at each point you discuss, you basically just you can introduce a little bit about the rationale. So here, so we analyzing unit tests, right? So why? So maybe I write a few questions for you to answer on this slide. For example, we need a code coverage. So the question is that maybe I can ask a very naive questions. Why we need a code coverage for unit tests? And the second question is why we need a mutation score for the test cases. Maybe we can start with the logics of these questions so that the audience and students can fully grasp the point of testing.
Okay. Okay, so regarding code coverage, instruction coverage in particular, the idea behind this is that your code has different branches they can take or instructions they can be executed, and you want to test to make sure that the functionality of all these are robust. So when you run a test suite, if it covers all the instructions, so in this case, the optimal case would be 100% instruction coverage, then you know that if it meets all the desired behavior, that it should be sufficiently robust to the behavior should be sufficiently robust, and all the instruction, every functionality of your program should be covered.
Okay, so maybe I can make a small comment here. I think Darien introduced it very clearly, and maybe I can comment or complement an example here. So if we want to test the program, I think you all taking the top engineering courses, right? So if we want to test in a program, basically, we want to test whether the programs work well in every code scenarios, right? So for example, if we are building calculators and we want to know whether the plus can work well, whether the operation of the minus, the subtraction work well, and how about we combine the plus and the subtractions, and what if we increase multiplication factors? So if we want to test the programs, basically we want to know whether every scenario, and whether code works well in other scenarios. But the problem is that how to define what is code scenarios, because the code is general. For the calculators, we can design scenarios. But if we train another programs, what are scenarios are there? So in this case, we are trying to define a set of the coverage criteria. Basically, we want to cover what we want to cover is a cover of scenarios. But the challenges to define scenarios is too hard. So now we look into different coverage criteria. For example, what Darien showed here is an instruction coverage. Instruction coverage is that instruction coverage is more like a statement coverage. That means we want to generate the test cases, while the test cases will pass or exercise every statement in the code. So that is very sensible, right? So if some statement is not covered by some test cases, by our tests, So we never know whether what the code whether that statement or whether the uncovered statement will perform during the runtime, right? So the instruction or statement coverage gotta be very normal. And also there is some branch coverage. That means every program branch will be covered. So we're using branch to simulate the scenarios, right? So that's a basic idea of the code coverage. Okay, Darien, keep going on. Maybe now you can introduce what is mutation score.
Yeah, thanks for the explanation. So the idea behind mutation score is that, for example, when you make a change to a program, you might accidentally introduce a regression, and you don't want that. So a mutation score aims to kind of do a similar check for that by introducing mutants. So you just mutate the program by a little bit here and there, changing some statements. Maybe you change a plus sign to a minus sign, or change one variable to a constant, and so on. And you expect that the test should fail if you do that. And so this is what it means by mutant be killed by test suite. So the test fails due to the mutation. And so a mutation score is the percentage of killed mutants with the total number of mutants. And so the idea is that you can use this as a proxy to kind of see how robust your program is against changes that might cause regressions. So now here's the first audience question. Is a higher or lower mutation score better?
Okay, so maybe you can select an audience in the group. You can either find someone you're familiar with or unfamiliar with. So you can find one to answer this question.
I'll choose the first person to listen. Dorcas, do you want to answer this question?
Dorcas? Hello, Dorcas, are you there? Okay, the mic of Dorcas is not working, but I suggest Dorcas, you can fix your mics, and I hope that in our group meetings, despite Xianglin didn't prepare the questions, but in the following presentations, we encourage and I think the speakers will always prepare the questions, and I think you may well prepared for that. So Darien, can you find an audience there?
Kelsey?
Hello. I think lower is better.
Okay, the answer is actually a higher mutation score is better. So the idea behind this is that when you make a random change to the program, most likely you will break the test. And so the higher your mutation score, the more sensitive your tests are to random mutations in your program. And so the more robust your test is, the more robust your program is in a sense. So it's just like not a direct correlation, but the authors have cited some studies that mention that mutation faults are similar to real faults. And so a higher mutation score is
implement an example. This is also a basic idea or basic concept of software testing. So suppose we have program P, right? And in order to test P, we have a set of test cases. We saw T1, T2, and Tn, right? We supposed to, and each test consists of the assertion A. So for example, an assertion is going to evaluate whether the outcome of the program when we're running the programs is equal to our expectation. For example, for T1 expected the outcome supposed to be 1, and for T2 it expected in the scenario of T2 we expect the outcome to be 0, and in etc. So we also outcome to be 100, whatever it is. Okay, so here the problem or the rationale of the mutation score is that suppose we have untested cases, okay, and we want to know whether these test cases have high quality. So that is the basic idea. So the mutation score. So here the coverage basically is for the program and whether given test cases and how much of the code or the programs or type of programs have been covered. And for the mutation score, the basic idea is going to evaluate given a P and given a set of the test cases, whether the test case set is of high quality. The mutation score is going to answer these questions. So how to answer these questions and how the mutation scores work is that So suppose we randomly change P into P prime, right? Suppose we make such a transformation. And by right, if the P is changed a lot, and a lot of the test cases will not work anymore, right? That is intuition. Is there any problems on this side? On this point? Okay, so that means if we change P into P prime, for example, under the program P, suppose all the test cases is to pass. But if we randomly change the P into P prime, a lot of test cases will not work anymore, so they will be turned into a failure. Failure means that the outcome of P prime will not be conformed to our expectation anymore, right? That is intuition. So here comes to the quality of test cases. Suppose the test cases of low quality. The low quality, for example, I change means assertion true. Assertion true means that whatever P change, this test case will always pass. Okay. Okay. So in this case, the more number of the test cases fail if we change the program, and the higher qualities of the set of the test cases. Okay, so that's the basic idea of the mutation score. So when we want to calculate the mutation score, the idea is that inside the P, we randomly mutate or change a few statements, and this change statement is called the mutated statement. Okay. So once we make such mutations, we will transform P into P prime and we observe how many test cases will be killed yeah. So here that means how the end test is failed with mutations. So the larger number of test cases it fails, it means that the more number of test cases it is killed, the better. Okay.
Okay.
Okay,
Yeah.
so that means the higher the mutation score is. Of course, there have a lot of the metrics to calculate the mutation, score, but the idea is just like this.
Yeah.
So the takeaway here is that the coverage per se is going to evaluating whether the test case, whether the program is per se, whether the program has been fully tested, and the mutation score means that whether the test cases to test the program is of high quality. Okay.
Yeah.
Keep continue.
Yeah.
Here,
So the next
here you're saying
slide.
that mutation score is the percentage of the killed mutants. So how do you define the Q, the word Q here?
Oh, it's the previous point. So a mutant is killed by the test suite if that any test in the test suite fails on the mutant program.
Okay, that's another kind of evaluation. So in this case, it means that given the P, and we apply a lot of the mutation here. Here's the P prime 1, P prime 2, and P prime on here. So we're going to see if we make a transform, make mutations, and I hope at least some of the test cases can detect such a mutation, right? If it can be, so here, so basically the Q is equivalent to be detected. So the more number of the mutation can be detected, the better, the higher qualities of the test cases.
Yeah. Okay. Yeah. So the next was just an example of how mutation score is computed. So just a quick example. We have the base program. We mutate the program in 3 ways, for example, and we have some tests here that just test with the functionality of this method. So yeah, it's just showing how mutation is calculated. So it's quick. As a quick question, I suppose would be what is the mutation score for this example? For this this one test, not really a test suite. So here we have 3 mutants.
You can audience question, right? Okay, so you can have a try to ask some audience.
Yeah. So let's see. Does Yishan want to answer this question?
Yeah, Yuchen, will you please to calculate the mutation score here?
Hello?
Maybe you can think aloud. Hi, Yuchen.
Okay. I think just now my mic wasn't working. So the mutation score is a percentage, right?
Yeah.
Okay, then it should be 1/3, right? So
Yeah,
because
correct.
the last two passes.
Yeah, correct.
Actually, I have a question about this mutation score, right? So if my test is about like handling exceptions gracefully, then doesn't that mean that the mutation score would be quite low?
Yeah, I also wanted to ask this question.
So you want the exception handle exception gracefully.
I suppose
Yeah,
if it's
so
kind of like test like the exception recovery from an unexpected situation, then if you mutate it, it's supposed to recover anyway. So it will never break the test. It will never be detected in that sense.
Sorry. So I forgot. I somehow get confused. So where is exception handled? For example, giving these examples, where is the exception handled there? Can you raise
No, I think what usually means is that we have some hypothetical case. So where we have a program, and we have a test suite that tests how well the program handles exceptions gracefully. So in this case, even if you mutate the program and it throws an exception, that wouldn't change the behavior of the program because you'll still handle the exception gracefully. So it wouldn't fail the test suite in essence. So it's asking like how that would mesh with
if you are testing whether the program can handle the exception gracefully,
Yeah.
we definitely should have an assertion, the right assertion here, right? So we somehow need to define the cases. Well, if we have exception, we raise exceptions. If it's throwing exceptions, the assertion is supposed to be false. Otherwise, it's supposed to be true, right? So this is a test case we're supposed to use to testing whether exception happens, right? So in this case, we just want to test if we insertion the mutations. If that's the case, as long as our mutations will incur exceptions, then it will be killed by the test, right?
Perhaps Yuchen want to explain further your question.
Sorry.
I'm a bit confused also, like where the discussion is going. So the assertion part, we can maybe just say that, well, I assert that I have a try-catch block, and then I make an assertion.
If it catch the exceptions, it assert to be true, or otherwise it was supposed to be false. So is that what you mean? The test, how you write a test case?
Yeah. So let's take that as the setup, right? Then, so if you introduce a mutation to the program, then it is equally likely to go into the catch block, right? So in that case, even though I introduce the mutation, it's still behaving as intended, and this would make the mutation score low, which we establish is bad.
Yeah, so that means that your test case, the quality of the test case is bad. You can see you change your statement, right? It will cause exceptions. By right, the program semantics has been changed, but your test cases per se does not kill it or does not detect it. That means the quality of such a test case is low. So in order to further improve the test suite or test cases, we need to add new test cases to detect such a mutation or kill such a mutation.
Okay, so the assumption is also that like your test suite has a certain quality, right?
Yeah. So,
okay.
So my point is that if we make some mutation, but the test cases behave at its original version, it means that those test cases have low qualities. So the mutation score is not to evaluate the program. The mutation score is going to evaluate the test cases.
Okay.
Okay. Does that answer your question, Yuchen?
Oh, you can.
Sorry.
Is that questions? Do you see any confusions or the other questions?
No, I think I'm clear now. Yeah.
Okay. So feel free to interrupt us. Okay.
Yeah, this is my first presentation. So if anything's unclear, just feel free to just interrupt and ask questions. Yeah. So now we come finally after all that info dump to the main problem of the paper, which is to look into the effectiveness of automated unit test generation on these machine learning libraries. And the reason why this is important because machine learning libraries are fundamentally different from general software projects. So the example is that they have is that they're usually data driven. So rather than general software projects, for example, code that's just well defined as a function, it just takes in one thing and spits out another thing. Machine learning libraries usually don't have the functionality written in the code directly. So instead, you need to supply the data and whatnot, and the code is just really just to manipulate the data. So this a stark difference from general software projects. And they usually have quite a lot of similarities with each other as opposed to general software projects. You can't really like find any similarities between general software projects as opposed to machine learning libraries, which all, aside from small differences, have the same algorithm, implement the same algorithms and have the same data processing steps, for example. So this means that the existing research on general software projects and the effectiveness of automated unit test generation on them is not applicable to machine learning libraries, hence the need for this paper. So the authors will propose 4 research questions. So first, asking about the quality of current unit testing in machine learning libraries. So in the case, the owner's original test suites, how well they perform based on the 2 metrics we mentioned earlier, coverage, code coverage, and mutation score. How effective the automatic unit test generation tools are on the libraries. What are the covered and uncovered code for the original test suites, and to what extent the automated tools can help us with testing the machine learning libraries. So straight up, we have 3 challenges that challenge the validity of this paper.
Terence, will please go back to the previous slide.
Yeah.
So here, so this is the typical research work of empirical study. So what is empirical study is that in this work, it does not propose any novel technique to address the problem, but they propose the problems and they are going to evaluate. How about the state-of-the-art techniques are used or work applied on these problems, and these empirical studies is supposed to lead us some findings and point about some future directions, which might lead to the further research work. So for infant, maybe you can pay attention. So you can see the structure that first it provides an introduction of the problem definitions. Then we'll introduce what is measurement to measure these problems. Then to raise a few research questions to evaluate the problems, and then follow up is supposed to be some experiment design, and after that supposed to be result comparisons, and then we're going to discuss the results and to see and extract the findings here. So based on this structure, there's a huge pie of the empirical studies in the field of software engineering. But of course, this is supposed to be a template. As long as you follow the template, you will have a paper. Anyway, that is a very good. Let's look at this template here.
Okay. Shall I move on?
Yeah, keep going on.
Okay. So again, we're talking about the 3 challenges to the validity of this paper's results. So the first is that the authors, later I'll show exactly which tools are selected. But in this paper, the authors select 5 machine learning libraries and treat them as representative of the general corpus of machine learning libraries. So the first challenge here is that whether it's valid to generalize results on these 5 libraries to all. Oh, sorry, it's the second one. Sorry, this one's about the automated tool. So the authors only choose 2 tools, Random and EvoSuite, which are supposed to be a representative of each approach to automated software test generation. And so the question is whether or not it's valid to generalize the results of the analysis on these tools to all the other automatic test generation tools. The authors think so because they say that the techniques and whatnot used are largely language agnostic, so it's not really dependent on the tool particularly used, and the other tools use similar techniques to generate the results anyway, so it's valid to do so. The second challenge is the one I actually mentioned earlier about whether it's valid to generalize results on 5 libraries to every other machine learning library, especially those written in other languages. The ones here specifically are written all in Java, the ones that the authors chose. Whereas there are also other machine learning libraries written in a language like Python, for example, which are largely popular. So it's also a valid question to ask whether or not it can generalize results to these other languages as well. And finally, the third one is whether or not the test cases themselves are legitimate in terms of the generated test cases. So, for example, test cases for machine learning libraries may use the initialization of these machine learning libraries may use, for example, parameter files and so on, which the test cases cannot simulate. So it's the question of whether or not these test cases can even test these machine libraries functionalities appropriately. Yeah.
But
so
here also just test cases, right? So that means they will generalize the test cases to the machine. For C1, the first challenges. So you mean they generalize the test cases to other automatic testing tools, right? Or the results of the test cases, right?
The results of the analysis of the test cases, I think.
Okay.
Yeah.
So and intuitively speaking, all the answers are supposed to be no, right?
As in, the authors provide some arguments to why they believe that these challenges are not they don't threaten the validity of the paper, but intuitively you could these be the 3 questions that you ask about the results first. So are these are these specific? Can we generalize them and so on?
So here, and you want to see that the first challenge means indicating that different testing tools can perform the same on the same machine learning libraries. So is that the cases? Is that you want to ask?
More like is it possible that other automated test generation tools may perform differently on these machine learning libraries, the ones that aren't explicitly analyzed by the authors?
Yeah, I think so. The most important question to me is that whether the generated test cases are legitimate. So that is the challenge 3. And basically, I think that these challenges not only for the ML libraries, but also for different, but also for the other code framework. So sometimes if we just cover the branch, want to cover the branch or cover some instructions, that'll be super easy. As long as it is covered, and that is all. But sometimes you know that in practice, for example, in some company like Shopee, Facebook, and people write test cases still manually because those test cases actually including some semantic informations, high-level semantic information. So here I just also very curious about the legitimacy. Okay. So let's keep going on.
Yeah. Okay. So finally, we get to the approach. So what the authors did to look into these research questions they mentioned earlier. So as mentioned before, the author selected 5 Java-based machine learning libraries that are widely used. And in order to get a comprehensive spread, they chose 3 from academic research studies and 2 from open source community-led libraries. So this, in their opinion, will allow them to get a good look into whether there are any differences between those libraries maintained by academics versus those maintained by open source community-led. So the approach is that they split the classes in each library into the 3 categories mentioned before: data processing, core model, and util. And the way they do this is that they first read the Java documentation to classify what each class does. And then if that doesn't disambiguate it, they read the source code to try and find out what it does exactly. So after splitting these into 3, they analyze the existing unit test quality using these 2 tools. So PI test for mutation score and Jacoco for instruction coverage. And now we talk a little bit about the procedure that Jacoco uses to analyze the instruction coverage. So how it works is that they create instrumented versions of the original class definition. So the idea is that they take the code, and they just add in essentially sensors along the steps to trace execution, and from there they can figure out the instruction coverage. Next we talk about how PI test does.
Please be more specific on the tree, right?
Yeah.
So,
Okay, so the tree here is just talking about the different kinds of coverage, and the orange notes indicate the kind, specifically the kind that Jacopo does. So there are many different kinds of ways to track code coverage apparently, and the way that it does it is that it instruments the class definitions, but it sticks in like probes to tricks execution along the way. Yeah. So there are also other kinds.
So are you here? Are you familiar, or have you checked the details of all the leaf node there? So
no, I read a little bit, but not much.
Okay, so maybe I just raise a question here. It's better for you to check it. I just feel that you may not have the answer for that. So my first question is that, so usually when we do the implementations, we always do it on the fly because it would actually save a lot of efforts for us to do this. But even for the Java engine, you still need a class loader. It is, for example, if we are doing this on the fly, so once the Java virtual machine is loading some Java class or Java bytecode, it always using class loader to do this. And when they use the class loaders, they need to modify the bytecode and run it on the modified version. And then how to distinguish the class loader version and the Java engine version? Because the Java engine version was still using the class loader to load the class and do the transformation, to perform the transformation and the instrumentation. So this is my first question. And my second question is about the runtime profiling. And it's better for you to distinguish between the JVM PI and the JVM TI. So basically, there are two frameworks provided by the JVM for the users, for the application, for the Java application to interact with the JVM machine. So it's better for you to distinguish, understand the difference between the JVM TI and JVM TI.
Okay, I'll probably have to do some research about how exactly.
Yeah, maybe you can fix the notes and then we can discuss the questions. Maybe you can prepare slides for the questions when you do the next committee meetings. If any other students are interested in these questions, you can also discuss with parents and also start the discussions in our group. Okay.
Yeah. Okay. Okay. So now we'll talk about how PI test calculates the mutation score. So again, bytecode manipulations involved. According to the PI test website, what they do is that they first identify where we can introduce mutations, and they record these areas, and then finally they spin up a new JVM instance to test the mutant by first mutating it, and then they run the whole original test suite on it. So this is the last audience question here. There's a trade-off here between the default setting, which is to spin up a new JVM per class, and what is exactly the trade-off here? So there's a trade-off of performance versus the soundness of the whole mutation score testing. What exactly is this trade-off? Does anyone want to answer this question?
Okay, so maybe I'm going to repeat the question here. So if we are going to apply the mutation, particularly the mutation score, there are two alternatives. The first one is that the first one is supposed to be statically, right? So given the bytecode, we just modify it and run it, right?
Yeah.
And the second is that it's kind of dynamic, right? So we start a new JVM and load the mutated version into the JVM. All right.
Yeah. Well, I think actually the way it was phrased was the trade-off between how often you set up a new JVM. So was it, for example, you can set one up per class or per method execution, and per test setting. So the question was what the trade-off here was. Yeah.
So I still have a little puzzle. For me, even me, I have some problem to understand the questions here.
Yeah, probably I'm not very clear on this part. Sorry. Okay. So I'll try and go over it again. We have these mutation points where we can identify potential spots where we can mutate the program. And so once we have mutated the program, we have to set up a new JVM, a child JVM process to test the mutant. And so there are choices on how often you spin up a new JVM. So you can spin up one default setting for PyTest, for example, to spin up a new JVM instance per class under test. But there are also other settings where you can spin one up, for example, for every test case, for example. And so what is the trade-off being done here? Why would you want to choose one over the other, for example?
So let me repeat it, further repeat it. So giving a program P, we will have the mutant P prime, right?
Yes.
And this P prime is created in a static way or dynamic way? Statically.
I think statically, yeah.
Okay, so my question is, what is the two alternative? The first alternative that we start a JVM.
Yeah.
We start a JVM to run P prime, right? And what is the alternative? What is alternative? And what is one options? I didn't get it.
Okay, so the alternative I think was that we either set up one new JVM per class, or we spin one up for every test case that we have.
因此 they are the same. So we started JVM for every Java class. So here we started JVM. So suppose this is a JVM, right?
Yeah.
We want to and that is a test case T1. Okay, let's call it T1. And by right, we should load P prime plus T1 into JVM and to get a result, right?
Yeah.
And what is alternatives? Can you mark on my graph and to have a more explanation?
How would I put it?
You can just hover your mouse on the top of the screen and there will be functions. And then you can just click annotate and then you can write something on the screen.
Trying to think of how I would say it, because this part is also a bit confusing to me as well.
Yeah, I just feel a bit confused about your question.
Yeah, perhaps I should restructure it and I'll come back to you on this later. Yeah. Okay, let's just skip this portion. It's a bit confusing.
Okay, so here basically, so I think maybe in my mind they have the different. So I don't know. So suppose we have a mutation P prime, right? So maybe a more convenient way is that when we have a JVM, right? And suppose we start and suppose we loaded the program P into JVM, and we load it on runtime. We load on runtime. So suppose we are mutation in class C, right? And this C is suppose we are testing C, and we are using implementation to mutate C into C prime, right? And
yeah.
We mutate C to C primes. We're supposed to start a new class loader, and we load every stuff. We load every class. We load a C prime into a new class loader, and let test case and let this class loader to run all the versions. So by this case, there's no need for us to statically load a class. So let me recap what I mean here. So this is JVM, right? This is JVM, and we will like to test a Java class C. And once we want to, so there are two alternatives. The first is that we apply the source code change mutation or like source code mutations. We create a C prime. Then we let the test case to test the C primes, and we load all the stuff into the JVM and get a result. This is the first alternative. The second alternative is that, let me use another color. The second alternative is that we have a Java class C, and we do not transform it. We do not create a stack file. We first load C into JVM. During the time the C is loading, we're using the class loader. Here I use CL to load the class. During the loading, we change C into C prime and let JVM to run. And this means we can avoid the time to write an IO to do the performance and to say the performance. So in this case, I think the best performance is supposed to be loading and then transform C when we load into class loader and then JVM to run it.
I think so too, but I'm also not too sure. Yeah.
So maybe we can skip this one and maybe let's keep going on.
Yeah, let's just skip this one. Sorry about that. Oops.
Yeah, when you propose questions, it's better to be a little clarified and yeah. So basically, the purpose of questions to complete them.
Yeah. Okay. Yeah. So okay. So next is on the approach for analyzing the effectiveness of the automated test generation tools. So what the authors did here is that they first generated test cases, of course, and they mentioned particularly that they remove flaky or uncompilable test cases. What we should define as either non-compiling tests or tests that did not pass 5 times in a single iteration. 5 times in a row, sorry. And next they run the aforementioned tools to get the coverage. They mentioned specifically that due to time constraints, they couldn't actually run PyTest on all the classes in each library. So instead what they did was they just did a random selection of 20 classes from each category. So I suppose this is a potential, it raises potential questions about how valid the results are. They didn't actually test on every single class in the library. So finally, they talk about analyzing coverage of the original test suites. So here again, they didn't test every one of them, I think, because of time constraints again. So you just selected 10 classes from each category per library. So that's 10 classes for 3 categories for 5 libraries. So that's 150 classes total. They fetch test cases for each of these classes and they collect the uncovered code using Jacoco. Next, we talk about how they analyze the improvement in the coverage using our test generation tools. So use the same 150 selected classes. They check the uncovered code blocks and check for the new test cases whether they covered the code blocks or not. And finally, they calculate the percentage of removed the improvements based on the generated test cases. So finally, we come to the results of the experiment. So what the authors found. So first, we talk about the existing test suites test quality. So you can see this table is a lot of data. We split it up broadly into 2 categories here. So first, the ones about the academic machine learning libraries and the ones about the open source libraries. So we can see that the average coverage for the academic ones actually much lower than the average coverage for the open source libraries. And the same goes for the mutation score. And in particular, this is a very poor coverage for the util classes for this one library, Weka. So the authors noted that the coverage in general for machine learning libraries is less than more general open source projects in general. So next, they also looked at the effectiveness of the test generation tools. So what I've covered up here is just some unrelated data, just about the number of generated tests, not very relevant to our discussion. So I just covered it. So the boxes highlighted in red show the important statistic, which is the delta coverage. So the increase in coverage for using the tools versus the original test suite. So we see good improvement in coverage for most of them, more so for EvoSuite than Randu. But we also see some cases where it doesn't quite work. For example, here, you see in Mahot, you only have a 0.4% increase coverage, which is basically nothing much at all. As an aside, the authors also noted that the percentage of uncovered code average was about 45.4, which is pretty significant if you consider that the average coverage of general open source projects is about 70%. So here the authors have also collated the overall increase for each type of for each unit test generating tool and the project. So the authors concluded that they lead to clear improvements, but limited improvements. In general, you still see almost about half the code is still uncovered, even with the generated test cases. This is just a highlight. This is expanding what was shown earlier, which is that all the libraries don't actually test all the functionalities. They test like part of the supported valid functionalities. So I think the most common case the authors mentioned was that the test cases did not cover all the valid behaviors. For example, some parameters that could be set were not set, for example. So some branches or some instructions are not tested at all. The authors mentioned 5 types of uncovered code. So this definitions here will be important because the authors talk about how the improvements from the generated tests can be split into these 5 categories and talk about the possible improvements or where it's possible limitations for the test cases. So the first is a lack of testing valid behavior. This is what I mentioned earlier. So for example, the test cases don't set a valid parameter, or they just ignore some parameters, so they don't test certain valid behaviors. The second one would be testing invalid behavior. So this is the same issue, just in reverse instead. You don't set some parameters to be invalid values. So you never test what happens when you go beyond like parameter bounds, for example. And the third one, exception. So this is like what you should mention earlier. So right, they don't test what happens when you enter an exception branch. So you're supposed to throw exception, but they don't ever set the parameters to force the program to throw an exception. So they never test that section. They also don't test auxiliary methods. So what this auxiliary methods here refers to is, for example, all those helper methods that you have, or helper libraries. So for example, if you're dealing with machine learning, you might have statistics about it, and you might have things that you have functions to help you return the standard deviation of something, for example. But these methods aren't actually tested by the test suite. So this is also a potential blind spot. And the last one is the lack of testing message handling behaviors. So what these are, for example, where you have helper methods help you print or to print out or convert certain objects structures to string, for example, for message passing, basically. So these aren't tested as well. So the authors now split the uncovered code into these 5 categories, and we can see how the uncovered code is split across the 5 categories. So in particular, auxiliary code is the one that's most commonly not tested, which it's quite understandable. So for example, if you're writing some core logic, you wouldn't think much about testing the side helper method, which is seen as supposed as less important. And then you finally, after that, you have the valid behaviors, exceptions, and message handling behaviors that are higher up for not being tested. But the ones that show up least in uncovered code is actually invalid behaviors. So I'm not sure what to make of this. The authors didn't place much emphasis on this result either.
So the question here is which one is most important, and also technically is there any rules and heuristics for them to detect this kind of code, right? And what kind of code is considered the VB, and what kind of code is considered in VB, right? Invalid behaviors, and how they classify the code like this.
Yeah. So for this, what they actually have, the authors actually have some definitions for what exactly these things are. So, for example, for valid behavior, the one you mentioned, the idea is that a class can have multiple valid behaviors. So, for example, when you introduce a parameter to a class method, there's a range of valid parameter, for example, and not all these behaviors are tested. So in certain cases, for example, like certain default.
Even for a Java method, it can contain both valid behaviors and invalid behaviors, right?
Yes.
So how they classify it based on classes, methods, or code statement. I found it's very hard to make such a classification, especially given a project like Weka for NLP, etc. It's very hard to, if we know this part, it will be very useful. But how do they classify those code?
They gave examples of how the definition come about, and they gave examples of certain test cases that did and did not do this, but they didn't actually, the authors didn't actually specify how exactly they, for example, they process the entire set of uncovered code to figure out, to split the categories. So I'm also not too sure as to how they did this.
Okay.
Yeah.
So my thing is that not every line of code needs test or needs coverage, but some of the code need to test a lot of times. So does also mention this point here, or okay, let's keep going.
Yeah. Okay. So finally, we come to the most important part, the improvement of the unit test generation tool. So how much improvement do we get out of these applying our test generation tools? So we can see overall, you can see some pretty large improvements, and the largest improvements come from the auxiliary and message handling behavior side. And the authors, what they believe explains this is that the auxiliary or message handling behaviors don't require input arguments, only need simple input arguments. So they make it a prime target for our automatic test generation tools to handle. But for the other 3 categories, they are more nuanced. So, for example, you need test cases with certain you need certain semantics in your test case. Like you need a test case to test valid behaviors, invalid behaviors, and so these make it more difficult for the test case generation tools to actually work on these categories. So the authors conclude that these two categories can be significantly helped by the generation tools, but the other three, improvement, although quite good, is still limited overall. Yeah. So to finish off, the takeaways from this, for me at least, was that machine learning libraries are fundamentally different from general software projects. They're not comparable in a standard sense, and so the standard testing approaches might not work. And because of this, our current automated tools, which are tailored for general software projects, can only go so far. They have certain shortcomings that don't make them entirely suitable for testing machine learning libraries. And the last one is that testing suites for machine learning libraries, human written ones, are usually not comprehensive.
The human written or machine generated suits. So there are research questions saying that whether the test case generated are legitimate. So what is the answer for that?
That wasn't actually a research question. That was a limitation, I believe. The authors never actually talked much about the legitimacy of the test case. I think they just assumed that it was legitimate, but it's just a challenge to the legitimacy of the paper. That's in whether or not these test cases actually serve to test the functionality of the machine libraries. The authors don't actually address this issue, I believe.
Okay. So I think here it is a very interesting papers, but I just feel it brings little the information. But anyway, the what to say is inspiring. And usually in terms of social testings, and comparing to generate test cases to exercise certain branches, it is also very important for us to decide which part of code need to be covered, need to be tested. And maybe we can have some other, I think there's supposed to be the research directions for address these testable or testability issues of the products. And okay. So that is my comments. Is there any questions for Darien's presentation?
Sorry, can I ask? I think fundamental question, because I'm not that familiar with this. I mean the testing tools, something like this. For example, in ML libraries, for example, when we write the ML code, actually we only need to call their a function, and then, for example, feed them to train the model and then predict. So their testing generation, for example, the coverage, what does it mean, the coverage of the backend? For example, the function I called, not this line, but the line inside this.
Yeah, so basically they want to test whether the machine learning library is reliable. For example, when we input test cases, then whether the library crash. For example, whether data set is very large, whether the library is still scalable. Basically, I think they want to test these kind of the functions. But this approach per se, I think you have an extra point. The first point is that whether the inheritance test cases supported by machine learning library, like a Weka, is enough to cover those behaviors. And the second is that, the answer seems to be that the test cases in those libraries is not that sufficient, because it only can cover less than 20% of the code statements. The second question is that whether the existing test generation tools can further improve the coverage, and if they can improve the coverage, whether the generated test case is legitimate or is useful or comprehensible in this regard. And I think the answer is that they can improve the coverage, but the generated test cases may not that comprehensible. So the takeaway, I think, is that it is very far for us to using the fully automated test generation tools for machine learning library.
Okay, I quite not that I understand, because for example, the machine learning is also data driving.
Yes.
Yeah. Cannot that understand such. I mean.
Yeah.
Okay.
So for example, so usually machine learning library have a lot of parameters, right?
Yeah.
For example, SVM, they have a lot of parameters. Sometimes when we input some parameters like the kernel type, what if we input an unknown kernel type and how the library responds, right? So that's one of the ways to test the library. Or what if the library, what if we feed into the machine model with zero data sets, with zero data samples? So this is another corner case. They're going to just test them in a library. But I feel that it's still a long way to go. And also, there's probably no Oracle problems. So even if we generate test cases and it may incur exception, but more often than not, we need an assertion on Oracle to define whether these test cases reveal some vulnerabilities. But this paper does not include that part.
Okay, thank you.
Okay, so maybe we call this, let me call it a day. Thanks everyone to attend the meetings and see you next week. Thanks again for Xianglin and Darien. Bye.
Thank you. Bye.